area of triangle. So I try to declare two variables. One is a base and one more is what? Height. So there is a function called read. What is the name of the function? Read. So within read function, I want to input values to the base and height. Means I want to modify the values of base and height. If I'm writing here base equal to float of, okay, input enter base, and if I'm writing height equal to float of, input enter height, enter base and enter what is that? Height. What will happen in this case? You are trying to input the value to the base. You are trying to input the value to which one? Height. So you are trying to input the value to the base and you are trying to input the value to what? Height. But what will happen? It will assign the value to the variable base. So it look for the variable base in read. Is it variable base is there in the read? No. Then what will it do? It will create. It will create a variable base inside which function? Read. But I don't want to create, but I want to assign value to which variable? Global variable. Then I'm using here the keyword called global. Global base comma, what is that? Height. So this says that, okay, you are assigning, you're trying to input the value, whatever value you're trying to input, that value you are assigning to which variable? Base variable. And here this base variable is treated as what? Global. And whatever value you are reading and assigning to the height, and this height is also treated as which variable? Global variable. So that I can use this inside another function. So there is one more function called which one? Find area. There is one more function called find area, and I'm saying A equal to some 0.5 into base into what is that? Height. So it look for the variable base and height inside find area. Is it variables base and which one? Global. So access the value of base height. Access the value of base, access the value of which one? Height. And then print. Okay, area is. I just print which one here? Area. So there is the function here. What is the function? It is called main. So enter the base of the triangle and enter the height of the triangle. Area is 0.899. If you want only two decimals, just give .2f. So that will give how many precisions here? Two precisions. So that is 0.90. So if you want to modify, so you have to remember this. If you want to modify global variable value inside the function, we can modify it by using the keyword called global. By using the keyword called global. Suppose I want to declare global and local with the same name. Suppose in one function, I want to access global variable as well as local variable. For example, I said x equal 100. Now this is called as which variable? Global variable. And there is a function 1. And if I'm writing x equal to 200, this is which variable? This is which variable? Local variable. Suppose if I am saying print x, then I'll get which variable? Local variable. I'm saying local variable x equal to x. But I want to access even which variable? Global. Suppose if I say print x, first priority is given to which variable? Local only. So it will try to get the x value of function 1. What is the x value of function 1? 200. But I want to access which variable? Global also. Then how can I access the global? Then You are trying to use one function called which one here? Globals. You are trying to use one function called which one? Globals. Globals will return a dictionary. Globals will return what? Dictionary. Which dictionary? Global dictionary. It returns a global dictionary, and from that dictionary, you are accessing which variable? Global variable x equal to, so G is nothing but what here? Dictionary. And from this dictionary, you are accessing which variable value? X variable value. You are accessing which variable value? X variable value. You are accessing which variable value? X variable value. So this is a function main, and you are calling the function one. Okay. So globals is a predefined function name, and that will return. Now you can see local variable x is 200 and global variable x is what? 100. So in one function, when you declare local and global variables, when you declare local and global variables with the same name, local variable name is what? X, and global variable name is also X. If I'm writing X, first priority is given to which variable? Local only. So get the value of X of local, and what is X value in local? 200. But I want to access even which variable? Global. Then I cannot get the global directly, right? Because already one variable is declared with the same name or not? Yes. Then I get the global dictionary. Now this will return global dictionary. This will return global dictionary. So return which dictionary here? Global dictionary. Globals is a function, returns which dictionary here? Global dictionary. And from that dictionary, you are trying to access which value here? X value. This will return global dictionary, and from global dictionary, you are trying to access which value? X value. What is X value? What is X value in global? 100. So otherwise, it will try to get which value here? Local, right? So if local and global variables declared with the same name, okay, if global and local variables are declared with the same name, okay, you access global variables by using globals function, right? So globals is a predefined function which returns global identifiers dictionary. Global identifiers dictionary. So from this dictionary, we can access which variables? Global variables. Okay. For that, you are trying to use one function called which one here? Globals. So this is useful when local and globals are declared with the same name. X is X. This X will refer to the local, and this X will refer to what? Global. So this X variable refers to the local, and this X variable refers to what? Global. Okay. So first X will refer to the local, and second X is refers to what here? Global, right? So when I write X, first priority is given to which one? Local. But even I want to access which variable? Global. Then get the reference of which dictionary? Global's dictionary. Okay. Yes. So local and global. So the scope of local is within the function, and the scope of global is an entire program. The scope of global is entire program as well as outside the program. You can use these variables within the program. You can use this variable outside the program also. You can use it within the program as well as outside the program. Anywhere you can use it. Then next one is, this is about globals. Now you can write a function inside a function. You can write a function inside a function. Now writing a function inside a function is called as which function here? Nested functions. Writing a function inside a function is called as which function? Nested function. Okay. You can write a for loop inside a for loop. If you are writing a for loop inside a for loop, it is called as a nested for loop. If you are writing a for loop inside a for loop, it is called what? Nested for loop. Okay. If you are writing a for loop inside a for loop, you call it as nested for loop. For loop inside a for loop is called as a nested for loop. Okay, for loop inside a for loop is called nested for loop. In the same way, a function within a function inside a function, a function inside or within function within function is called a function within function is called which function here? Nested function. Or you'll say defining a function inside function. Defining function inside a function is called a nested function. So what is the need of writing this nested functions? What is the use of, or what is the need? What is the need of nested functions? What is the need of nested functions? So the first one is hiding functionality of one function, hiding functionality of one function inside what? Another function. Hiding functionality of one function inside another function. Okay, you'll be hiding the functionality of one function inside what? Another function. Second one is nested functions are used. Nested functions are used to construct special functions like decorators. These functions you constructed decorators and closers. Now you try to construct these special functions like decorators and closers by using which function here? Nested functions. So why you are using a nested function is hiding functionality of one function inside what? Another function. And nested functions are used to construct. This concept is used to construct the special functions like what? Decorators and closers. These functions are used to construct the special functions like decorators, and one more is what here? Closers. Decorators and closers are constructed by using which functions here? Nested functions. So it is as simple as like this. If you see the syntax of this, so there is an outer function. If you see the syntax of this, you are writing definition, and this is which function here? Outer function. And this outer function, you may write it with arguments. And inside this, you write some statements. Or inside this, you write another function. So this you can call it as which function? Inner function. or the same thing is called as which function? Nested function. This is called as inner function or nested function. Okay. Now in this, you're writing some statements. That is statement 1 and statement 2. So this you can call it as outer function. This is the outer function and this is there is outer function and there is what here? Inner function. Inner function or nested function. So a function inside a function. See here, a function inside a function is called as inner function or nested function. So where I can use this function only within outer function. So inner function is called inner function or nested function is called or executed within outer function, but not outside the function. Okay, inner function or nested function is called or executed within outer function, but not outside the function. Not outside the function. Inner function or nested function is called or executed within outer function, but not outside the function. Not called outside the function. Within outer function, you can call it, but not outside the outer function. Okay. Yes. For example, just try to understand this. Now, inner function or nested function can perform operation using data of which function here? Outer function. Inner function can perform operation using data of which function here? Outer function. Okay. So what is the meaning of this is, for example, I'm writing like this. First to see the fundamentals. I write here F1. F1 is one function. And this is which function here? Outer function. So how many statements are there in this function? Only one statement. And inside this, I write another function. What is that function? F2. So this is which function here? Inner function. So what will happen if I call the outer function? If I call the outer function, will it call inner function automatically? Yeah? No. I called which function here? Outer function. And what is the message I'll get? Outer function. But is it this function is called or not called? Not called. Because I called which function here? Outer function. It will execute all the statements, all executable statements in outer function. How many executable statements are there in outer function? Only one. How many executable statements are there in outer function? Only one. But is it this function is called or not called? Not called. So I have to call it. I'm calling now F2. So how many executable statements are there here? Two. One is print and one more is what? F2. How many executable statements are there? Two executable statements are there. One is a print statement and one more is which statement? F2 statement. If I run this, now outer function as well as what? Inner function. But if I don't call this, then it will execute the statements of outer function. But is it inner function is executed or not executed? Not executed. Then I have to call inner function. Now you can see there is outer function and there is what? Inner function. Outer function and inner function, right? Just to see here. So until unless you don't call the function, okay, until unless you don't call the function, function is not executed. Until unless you don't call the function, function is not executed. It should be called as an executable statement. The function should be called as an executable statement. If you don't call it as an executable statement, then it is not called. Okay, it has to be called as an executable statement. So you can have any number of functions inside a function. For example, I'm writing F1 within F1. So this is inside F1 function. And inside the F1 function, there is another function called which one? F2. Inside F2 function, inside F2 function, then I write F3 and print inside which one here? F3 function. So inside F1 function, inside F1 function, how many functions are there? Two functions are there. One is F2 and one more is what? F3. Then F1 should call F2 as well as what? F3. So F1 calls F2 and F1 calls which one? F3. So it calls the F2 function as well as F3 function. So called F2 function. What is the message I'll get inside which function? F2 function. Then call F3 function. Now what is the message inside F3 function? Then I call which function now? F1 function. So F1 function, how many executable statements? 1, 2, and 3. So what is the message I'll get inside F1 function? Then call F2 function and print inside F2 function. And call F3 function and print inside F3 function. So number of executable statements. Number of executable statements are 3. Okay. So whatever executable statements are there, it will execute those statements first. Whatever executable statements are there, it will execute those statements first. Okay. Yes. For example, I said inner function can perform operations using the data of outer function. For example, I'm developing a calculator. I'm developing which one here? Calculator. Okay, what is the name of this function here? Calculator. And I try to give some inputs. N1. So input, enter the value of which one? N1. N2 equal to input, enter the value of N2. So I try to input the value of N1. I try to input the value of what? N2. Then next one is operator. So which operation you want to do it? So input, enter the operator. Enter the operator. So calculator, the operations of calculator I'm dividing. There is a function called which one? Add. So inside the calculator, I have so many functions. Inside the calculator, I have so many functions. Inside the calculator, I have number of functions. So inside the calculator, there is a function called add. Okay, now it means further it is divided. Sum is N1 plus N2. Then there is a function called sub and print difference is I'm saying N1 minus N2. Then multiply is there. Okay. Then I'm saying product is N1 into what is that? N2. Product is N1 into N2. And then division. So print format result is N1 divided by N2 with how many precisions here? 2 precisions. Okay, it means the functionality of calculator is further. The functionality of calculator is further divided into how many functions? 4 functions. So instead of, suppose if any changes in add function, you'll be doing directly changes in add function without doing any changes in sub function, multiply function, and what? Division function. If any changes to be done in multiply function, you can do changes in multiply function without doing changes in add, sub, and what? Division. So maintaining code becomes what here? Easy. Then based on the operator, suppose if the operator is a plus, then I call the function add. Okay, else if operator is a minus, then I call the function called sub. Else if operator is a star, then I call the function multiply. If the operator is a star, then I call the function called which one? Multiply. I call the function multiply. Else if operator is a slash, then I call the function called which one? Division. So based on the operator, I try to call different functions. I just call the function calculator, but calculator internally calls different functions. Calculator internally calls different functions based on the operator. Based on the operator internal, it will call different functions like add, sub, multiply, and what? Division. So dividing the functionality of one function into number of functions. Dividing the functionality of one function into number of functions. Dividing functionality of one function. Enter the value of n1, which is 10. Enter the value of n2, which is 5. And I said operator is what? Plus. So I input the value of n1, which is 10, and n2 is 5. Operator is plus. Is it operator is a plus? Yes. Call which function here? Add function. And here it will add 2 numbers. Add 2 numbers, right? Now 10 plus 5 is what? 15. Okay. Then run this. Now enter the value of n1, which is 10, and value of n2 is at 20. And I'm trying to say operator is a star. Operator is a star. Then call which function? Multiply function. Okay. You can see the product is what here? 200. Okay. So it means I divided this calculator functionality into how many functions here? Number of functions. By writing functions inside a function. By writing functions inside function here. And that you can call it as nested here. So the output of your code is like this. So inner function can access. Yes. Inner function or nested function. Inner function or nested function can access local variables of outer function. Local variables of which function? Outer function. Inner function or nested function. See here. Inner function or nested function can access local variables of which function? Outer function. Inner function or nested function can access local variables of which function? Outer function. It can access the local variables of outer function. Inner function or nested function can access local variables of which function? Outer function. Okay. Yes. But outer function cannot access local variables of inner function. No. What is the meaning of this is function 1 is there. Here I am saying x equal to 100. What is x here? Local variable. I said y equal to 200. What is y here again? Local variable. X is a local variable and y is also which variable? Local variable. X is a local variable and Y is also which variable? Local variable. This both are local variable. X is a local variable and Y is also local variable. Okay. And inside the function 1, I am writing another function called function 2. So within function 2, I can access format x value of function 1. I can get x value of function 1. Okay. And I can write here print format. This is y value of which one? Function 1. And this is a y value. Okay, now. So in the same way, for example, function 3 is there. Inside the function 3, I said z equal to 300. This is local variable. This is local variable of which function? Function 3. This is local variable of which function? Function 3. Is a local variable of function 3. Z equal to 300 is what? Local variable of function 3. It is a local variable of function 3. Then if I'm writing print format z value of which one? Function 3. Okay, z value of function 3, I print which value? Z value. For example, here if I'm writing x equal to 500, what will happen? First priority is always given to the local or not? Yes. Is it any variable called x within the function 3? No. Then create. Create local variable x inside. Create a local variable x inside which one? Function 3. If I am writing y equal to 600, then create local variable y inside what? Function 3. But is it this is assigning values to the local variables of function 1? No. It's creating x and y variables inside what? Function 3. But it's not assigning this 500, 600 to what? xy variables of function 1. So if I'm writing here print, now this is local variable. Now this is x value of which one? Function 3. X value of function 3 which is x, and y value of function 3. And what is the y value of function 3? Y. Okay. And then I call here function 2 and I call here which one? Function 3. And this is main and called which one? Function 1. Means the inner function can access the local variables of which function? Outer function. But cannot modify it. If you are trying to modify it by saying x equal to 500, then it will create which variable? Local variable x inside the function 3, right? But if you want to assign values to that, now you can see the x value of function 1 is 100, y value of function 1 is 200, and z value of function 3 is 300, and x value of function 3 is 500, and y value of function 3 is what? 600. But what my requirement is, within inner function, I want to modify xy values of which function? Outer function. Okay, within, see, you can access outer function variable inside what? Inner function. Now this becomes non-local variables. For function 2, this x and y are called which variables? Non-local. For function 2, x and y are which variables? Non-local. Because is it x and y are there inside function 2 or outside? Outside. But outside these are local to which one? Function 1. So for function 2 it is a non-local. For function 1 it is what? Local. Then function 2 cannot modify the non-local variables. Function 2 cannot modify non-local variables directly. If you are trying to assign values here, if you are trying to assign values, what it is doing? It is creating new variables called x and y. It's creating a new variables called x and y in which scope here? Function 3. That is when you create with the same name. But my requirement is I want to assign this 500 to the x variable of which one? Function 1. I want to assign 600 to the y variable of what? Function 1. Then how can I access it? This can be done. Yes. This particular thing can be done. How this is done here is, so this particular thing is done by using one more keyword. So there is a keyword called which one? Non-local. One keyword is it. Global will refers to which variables? Global variables. If you want to modify global variables inside the function, if you want to modify global variables inside the function, you are trying to use a keyword called which one? Globals. Okay, right now just try to understand this. Okay, so non-local is there. So with the help of this non-local keyword, with the help of this non-local statement or non-local keyword, so non-local is there. So the non-local statement causes the listed identifiers to refer to the previously bound variables in the nearest enclosing scope, excluding which one here? Globals. Okay, this is important because the default behavior for binding is what here? Search in which one? Local functions, local namespace or within local. Okay, and this statement allows to access. I mean, if you want to access or if you want to create, then you can create or access the variable which is there outside the scope by using which statement here? Non-local statement. It is done by using which statement here? Non-local statement. The non-local statement causes the listed identifiers to refer to previously bound variables in the nearest enclosing scope, excluding globals. This is important because The default behavior of binding is search in which one here? Local. Okay. So how can I access it? I can simply write here. Yes. If I'm writing x equal to 100, if I'm saying x equal to 100, this is called which variable? Global variable. And I'm writing function 1. And if I'm writing y equal to 200, this is which variable? Local variable of function 1. If I'm writing here function 2, if I'm writing z equal to 300, this is called as which variable? Local variable of function 2. If I'm writing a print format, I want to access global variable x, I can access directly. Print, I want to access which one? Local variable of function 1, and that is nothing but y. I get the value of y, and print, this is local variable of function 2 z equal to which one here? Z. So is it this is accessing? Is it this is accessing or not? Yes. So for that I don't require to use non-local or global. I can access it directly. Now global variable x is what? 100. And local variable of function 1 y is what? 200. And local variable of function 2 z is what? 300. I can access directly, but suppose there is another function is there. What is that function here? Function 3. And within function 3, I want to suppose I write here some k equal to 400 or 500, and this is local variable of function 3. Local variable of function 3 k equal to which value? K value. Now within function 3, I want to modify which value? Y value of function 1. Within function 3, I want to modify y value of what? Function 1. Then how can I modify? I'll say non-local. Which one? Y. And then I said y equal to which one? Some 400. Y equal to 400, I said format. Okay, format. Format. Now this is local variable of function 1, y equal to, this is a y value which is modified inside the function 3. Which value is modified inside the function 3? Local variable of function 1 y is modified in function 3 by using which statement? Non-local. You can access it, but you cannot modify it. You can access it, but you cannot modify it. So after modifying, if you want to print it, just write. So local variable of function 1 is function 1 x is, as just print which value? X value. I call the function 2. I call the function 2 and function 3. And here called which function? Function 1. So which function is called first? Function 1 is called, and create y variable and print value of, print value of y. And what is the value of y? 200. And then call the function 2. And what is x value? 100. What is the y value? 200. What is the z value? 300. Then call the function 3. What is the k value? 300. And non-local y means y value changed from 200 to what? 400. And print y value is how much? 400. Right? If you want, you can print after modification, print local variable of function 1 y equal to which value? Y value. If you run this, y global y z k y y, after modifying, before modifying, what is the y value? 200. Before modifying, what is the y value? 200, right? But after modifying y value is what? Yes, 400. But how you modified? By using the keyword called which one? Non-local. Until unless you don't use non-local keyword, a non-local variable cannot modify it. Non-local variable cannot modify it inside the function. Non-local variable cannot modify it inside the function. You cannot do it. But Python uses one searching technique. How Python will search these variables? Python always, the first priority is given to which one? Local. Next priority is given to which one? First is given to the local and second one is non-local. Then third one is global. Fourth one is module. Okay, if it is not available, then it will look inside imported module. So Python will search for the variables or identifiers by using one searching technique or one algorithm, which is called as LEGB. 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 You call it as LEGB. Now, what is LEGB? The question is, what is LEGB? So Python search for identifiers are variables one searching using one searching method called LEGB. Using one searching method called LEGB. So where L stands for what here? Local. E stands for what here? Enclosed block. Enclosed block. G stands for global. G stands for global and B stands for built-ins module. Okay, built-ins module are the modules which are imported. So it will search like this. First priority is given to the local. Next is given to enclosed block. Next is given to the global. Next is given to which module here? Built-ins module are the module which is imported. The module which is imported, right? Now, first, so first priority is given to which one here? Local. First is given to the local. It will search in which section here? Local section. It will search in local. If it is not there in the local, then next, if it is not there in the local, then next it will search. If it is not there in local, it will search in what? Okay, if it is not there in the local, then it will search in. Next is given to what? Non-local. Next priority given to non-local. If it is not there in the non-local, okay, next is given to the non-local. If it is not there in the non-local, the next priority is given to global. Next priority is given to the global. It will search in global section. Next priority is given to the global. So if it is not there in the global, next priority is given to, okay, inbuilt modules or built-in modules. Whatever module is imported, whichever module is imported, in that module it will search. So B, built-ins. So next one is built-ins module. Next priority is given to the built-ins module. So built-ins module. So if it is not there in built-ins module, then it gives a error. Name error. Then you'll get which error? Name error. It will search in all the scopes. First local, not there. Non-local, not there. Global, not there. Built-ins module, not there. Error. Suppose if I'm saying print X, first it will look for X in local, not there. Non-local, not there. Global, not there. Built-ins, not there. Then you'll get which error? Name error. Okay, then you'll get which error? Name error, right? So it will search like this. It will search like this, right? So this you can call it as searching technique. The searching technique which is used by Python in order to search which one? Variables. This is a searching technique used by the Python in order to search. Variables are what? Identifiers. Variables are identifiers. Now that you are saying it as which one? LEGB. Okay. Now this is how you write a function inside a function. And writing a function inside a function, you call it as which function here? Nested function. Nested functions are used to construct. We can use these nested functions to construct some special functions like what? Decorators. You can use the nested functions to construct some special functions like what? Decorators, and one more is what? Closers. Let us see what is this decorators. Okay, decorators. So decorators are used, decorators are constructed by using which one? Nested functions. Decorators. Decorator or decorators. So actually it is a special function in Python. Decorator is a special function in what? Python. Okay. Decorator, which is very useful. And you find some decorators, predefined decorators in Python. And not only that, if you are working with certain frameworks, you find some predefined decorators. You find some predefined decorators to extend some functionality. You find some predefined decorators to extend what? Functionality. Okay, right? We'll see how to work with these decorators. Decorators, generators, closers. Okay. All these are some special functions are there. And we'll discuss about these functions tomorrow, right? So today we'll stop it here and tomorrow we'll continue this, right? Thank you.